This is the Algebra 2 video lesson for section 6.6, function operations. In this lesson, we're going to learn to add, subtract, multiply, and divide functions, and then also find the composition of two functions. So this is the notation for you're just adding the two functions. There's a function defined for f, a function defined for g. F plus g of x is the same as f of x plus g of x. And same with minus, times, and divide. You just have to make sure with division that your g of x doesn't equal 0. And you do that with the domain. You make sure, and that's what this is saying. The domain of the sums, blah, 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 consists of x values that are in the domain of both f and g. So whatever are the domains of f and g, that's where you start with. And then also the domain of the finished one has to have the same, can't have values that aren't in the domain of f and g, and then the quotient function also can't have any values that make g of x 0, so that will affect the domain as well. So let's look at an example. This first problem gives us an f and a g defined for x, and this is saying what are f plus g and f minus g, and what are their domains. So starting off with the domains of f, we first want to just look at what the domains are. So this is just a line, and the domain of lines is all real numbers. Okay, and I know domain just means what x value can I plug in? I can still get a y value to come out. So anytime we have a line or quadratic, those are always going to be, this is how I write all real numbers. This is just the cheat for that, just an R with an extra line. Okay, but the ones where there are going to be restrictions are when you have a square root, right? Because the square root of something, right, it can't be negative. So x for this case has to be greater than or equal to 0. And then the other thing is dividing. You can't divide by 0. So here b can't equal 0. So you just want to make sure when you're naming the domain, is there any denominator? I have to make sure that's not 0. And is there any square root? I have to make sure that's not negative. And so you can see here in g, we do have a square root here. And so whatever is underneath that, in this case x, has to be greater than or equal to 0. And that's actually the domain, because this doesn't affect anything. So you can write a domain like that. This is the domain. Okay, so that's where we're starting. So f plus g, this is the notation you'll see on the homework too for this. This is going to equal f of x plus g of x, which is just 4x plus 7. That's my f of x plus square root of x plus x. And then let's just combine these. 4x plus 7 plus square root of x plus x. These are like terms, so this just becomes, 5x plus 7 plus square root of x. And that is our answer. And then our domain, we don't have any anything dividing, so we don't have to worry about anything being divided by 0, but we do have this square root, so we need to make sure that this is, and this didn't change from here. So we always start with this. And so this is the most restrictive. So the domain has to be x is greater than or equal to 0. Okay, you can't have, x can't be a negative number, right? It could be here, but because now we've added it to this and the x can't be negative there, it still can't be negative here. Okay, so try this one on your own, press pause, and then check back for the solutions. Okay, so for this one, the domains are all real numbers because there's nothing being divided and there's no square root. And then when you add them together, just combine like terms here and here. There's still no dividing and there's still no square root sign, so the domain stays all real numbers. So any x you can plug in and there's no restrictions. Okay, so here's another example. This time we're doing multiplying and dividing. So the notation for this, which you'll see on the homework, is f times g of x. And that's the same as f of x times g of x. So then we'll just plug in our x squared minus 9 times our x plus 3. Oh, and I didn't state it. There's no dividing and there's no square root sign, so our domains is just our regular, all real numbers so far. That's what we're starting with. So there's no restrictions that we're starting with. And then here we're just going to multiply it out, FOIL, x cubed plus 3x squared minus 9x minus 27. And there's no like terms. So this is our answer. And then there's no square root signs or radicals. There are no dividing. So the domain just stays all real numbers. There's no restrictions. Okay. Oh, I forgot to do problem 1, the minus. Oh, sorry. I think you guys get it. You just do the same thing that we just did in problem 1, plus it, but then you minus it. So sorry about that. but I'm not going to go back. I'm sure you're happy about that. So this is the division one. So this would be f of x over g of x. And so here we put in our x squared minus 9 divided by x plus 3. And this actually, if you could factor this top, right, because this is difference of two squares. This is x plus 3 times x minus 3, and then x plus 3. The x plus 3's actually cancel. Look at that. And so the answer is x minus 3. But the domain, even though we've canceled something on the bottom, there is still a fraction. So there is a restriction on this x plus 3. This x plus 3 cannot equal 0. So if we solve for that, right, x cannot equal negative 3. So our domain, we now have a restriction. We didn't at the beginning, but see, we were a restriction because we did divide. Our domain is all real numbers except x cannot be negative 3. Okay? And let me just, because I didn't do it in problem 1, just f minus g is going to be notated f minus g of x. And then that's just going to be f of x minus g of x. So if we were doing it with this one, right, we would just do x squared minus 9 minus x plus 3. So this would become x squared minus 9 minus x minus 3. And then we would just combine these two, x squared minus x minus 12. And then there's no dividing and no square rooting, so the domain is still all real numbers. All right, sorry about that. So try this one on your own. So do the multiply and the divide, and then state if there's any restrictions on the domain. Okay, press pause, check back for the solution. Okay, so with multiplying here, you'll have to, I just did a table. You could do the long things, these two combine. So this is our final polynomial in standard form, and there's no dividing, no radicals, so the domain stays all real numbers. For the dividing one, right, this top one can be factored. You have to do the long way. It factors to this, and then the one factor cancels. But before I canceled anything, I stopped here as soon as I have something dividing, and I made sure to capture what's being divided and make sure it can't equal 0. So that value is negative 1/3. So in our domain, x cannot equal negative 1/3, even though it cancels. The answer is x minus 4, but the domain does not include negative 1/3 because of this here. Okay. All right, moving on to composite functions. So composite functions are functions within a function. So you can kind of picture like our function machine, like putting two function machines next to each other. So so here's, you have the domain of f. Whatever can go into f that gives something that comes out, goes in, and then out comes out. And then so that's my range of f, which is now my domain of this one here for the g. Goes in, right, the domain of g. The only ones that will spit something out for g, and then comes out. So this is g of f, and this is, you can see how it's notated here with this circle. It's not a dot. Multiplication is a dot. This is an open circle. So this is saying this is the outside function, this is the inside function. So this is the same as this here. So first you do the inside one, get your value, and then that goes into g. So you're basically doing, right, evaluate f of x first, then do f of x as the input for g. So again, like you can picture our function machines, right? The x goes in, f of x comes out, and then this value goes in, look at this weird function, to g, and so it's g of f of x, right? That's what goes in there, and then that comes out there. Oops, sorry, g of f of x. So it's just two function boxes in a row. So let's see how that works. Okay, and then this is going to be, we're going to be evaluating these at an actual number instead of an x. So let's see. So this is saying g is my outside function, and then my inside function is x. Okay, and then my x is actually is the negative 3. So this is g of f to the negative 3. So I'm going to keep that g on the outside, and then I'm going to plug my negative 3 into f. So right here. So this is negative 3 minus 5. And I'm going to evaluate that, which is negative 8. And now I'm going to plug negative 8 into g, which is negative 8 squared, which is positive 64. Okay, so you can kind of see with the function box. Man, that's a bad one. Okay, so the negative 3 goes in, and this is my f, right? Negative 3 minus 5, out comes my negative 8. Then I take that negative 8, that goes in my G. It should be open, sorry. It goes in my G, and it gets squared, right? This is x squared. This is x minus 5. And my x is now negative 8 squared, and then 64 comes out. Okay, so try that again, same negative 3, but with f on the outside, right? So then that means G is first, and then f. So switch these and see what you get. Press pause, try this on your own, and then check back for the solution. Okay, so hopefully you got 4, right? The negative 3 goes in the G first, gets squared, becomes a 9, and then the 9 goes in to the f, and it gets subtracted by 5, which is 4. Okay, that's it. There's your practice. Enjoy.